Hey folks, thanks for joining today's Augment Code in Action webinar. I know we have quite a few signups, so it's nice to see the participation. And shout out to everyone who met us at the AI Engineer World Fair conference last week. Had a lot of good traction there, met a lot of interesting folks, a lot of genuine AI enthusiasts. So excited to hear your feedback as you guys begin to use Augment. Now, what I have planned for us today is going to be a quick few slides where we talk about the state of AI for code, especially for the enterprise. And we'll shift into a demo of how we can use some of the features of Augment, some dev workflows across the SDLC that Augment can help enhance. And we'll open the floor for some Q&A at the end of the session. Now, when it comes to software development, everyone thinks that it's just about writing code. It's actually about thinking and changing the software you're working on. Now, the problem arises that, especially in the enterprise scenario, whenever you're working on software dev, you're usually thinking about architecture discussions. You're working on code that's not your own. Sometimes I'm working on code that's, my own from 6 months ago that I don't remember. So before I even start writing code, I need to think about dependencies, edge cases, data flows, patterns. The list goes on and on and on. And what this leads to is this inverse relationship between the complexity of the code base and then dev sentiment and happiness. Now, the reasons I just shared is why enterprise level AI for code is an unsolved problem. The AI tools that were present, or the first gen AI for code tools, don't really meet the mark when it comes to helping with more complex tasks. The more the company grows, the more the team grows, you're going to have knowledge silos that are present, a lot of tribal knowledge that seeps through the cracks, tech debt. And if you don't have that crucial context awareness, you're going to end up getting a lack of quality code. So with this in mind, let's take a look at how the first generation AI for code tools are architected. And they're all generally following the same pattern. They take the user prompt and they do some basic searching across the code base. They're going to use things like a grep. They treat code like flat text, and off-the-shelf algorithms are incorporated, such as using ASTs or Merkle trees. Now, once all of this, first pass is taken, one single prompt is created, and then the onus is on you as the developer to choose the right model for the output. And there's new models coming out every day. How do you kind of keep in mind, this is the use case I should use this LLM for? How many prompt credits or user credits will this model take? So at Augment, we took a fundamentally different approach. What we realized is LLMs are great at generating output, but it's a garbage in, garbage out problem. If the quality of the input isn't there, it doesn't matter what model you choose. So we spent 2 years building out this robust SaaS infrastructure that allows us to do a few things. One is we can keep a hyperscale real-time index. So what does that mean? We can actually have over 500,000 files open in the workspace, and Augment's able to index the entire code base. And we actually re-index at every keystroke. So it's going to keep up with all your changes in real time. We then combine it with our proprietary context engine. Now, our context engine understands the shape of code. Java is different from JavaScript, which is different from TypeScript. It's going to grok through your code base, get the core plumbing, understand your interdependencies, things like your JSON schemas, your queries, your unit testing. Once we take all of that crucial detail, we're going to construct a prompt based off of the task at hand. So completions are going to require snappiness and quickness in response. So we're going to use smaller modalities. Things like chat, where you have your more complex architectural discussions, we're going to use larger models to give you that verbosity and specificity. One thing you notice about Augment is we didn't choose to go the fork route. We did the work to meet the developers in their environment of choice. So we're an extension in Vim, NeoVim, VS Code, and JetBrains. And we're also not going to have you pick a model. We actually intelligently route between over 6 models. Some are proprietary, some are open source, and some are frontier models that our AI research team fine-tunes and post-trains and keeps up to date with, so you don't have to figure out what models to keep up with. You don't have to use generic model outputs. So you can focus on what you do best, which is coding. Now, the crux of this entire operation is this context engine. and extends to everything that we offer in the platform, including our agents. Now, with our agents, you get all of the benefits of that code-based understanding, along with the combination of native integrations via OAuth, which I'll share, MCP, and we also figured out how to use the native terminal in your IDE of choice. Speaking of agents, there's this incorrect notion in the world today that agents are going to replace entire phases of the SDLC. I'll have an agent for the create phase. I'll have an agent for the operate phase. What we found out, speaking to enterprises and developers around the world, is that agents are going to be really good at certain tasks in each phase of the SDLC. Now, the way first-gen AI coding assistants are architected, they're going to be limited to the plan and create phase, right? Limited to the resources on the local machine, limited to a fork. Whereas Augment, because we're able to abstract with the SaaS infrastructure, the goal is to extend that code-based awareness to all parts of the SDLC, from plan to shipping to deployment. Now, enough slideware. Let's get to the fun part, the demo. I'm going to demo primarily in VS Code, but we'll also shift to JetBrains for our JetBrains fanatics out there. We'll walk through features, show you how to use agents and remote agents as well. Now, the code base I have selected for us today is a pretty large proprietary code base on self-driving cars. So nothing's been trained on this, super complex. So let's take a look at how Augment can help me navigate something at this level. You notice that we're an extension. So once you authenticate, Augment by default indexes the entire workspace for me. And again, I don't have to pick a model. You can actually fine tune some of the setup. So in our settings tab, I can actually go in and add additional folders. So documentation, repositories to keep in Augment's context without having to open a different workspace for each one. We also have rules and user guidelines where you can direct Augment chat to follow certain instructions in natural language, such as use jest for all my unit test output. Now, while we were setting up, I actually had Augment write some comprehensive docs for a developer that might be onboarding to this code base. Augment was quickly able to give me a nice little summary, and then looking at not just the code base structure, but also relevant documentation and build files, provide a checklist on how to set it up, find out the key components of what's going on in this code base, and then breaking it down to things like, here's my GraphFlow language, here's the hardware platform. It also walks me through how to do the dev environment setup, where the monorepo is located, understood that I use Gradle, and then here are some of the workflows in terms of testing, how to do source bash, and then documentation as well. So as you can already see, Augment's really great at that information discovery and documentation phase, which is really crucial the more your team expands, where you don't want to accrue tech debt along with knowledge silos. But let's take a real world example. As developers, we're going to spend 90% of our time working on either a ticket or a story. I have here a linear ticket that's telling me to add confidence scoring to an image scene data structure. It has annotation points, so it's an array, and it's in this block library object. This is a pretty generic setup, and whether I've been here for 10 years or 10 days, it's impossible to keep all that crucial context inside my head. That's where Augment comes in as my pair programmer, where in natural language, I can simply ask things like, where is the data structure for image scene and block library? Now, I want you to notice the speed where Augment's going to quickly grok through my code base, and immediately it points me out to this scene Scala file. It understands that that's the file I should be looking at. It also breaks down an abstraction of how this code base is set up. So there's an annotated image scene. It has an array of lane data and images, and also understand that there's a V1 and V2 part of my code base. So I can simply click to the part of the code base I want to get to. And I can continue asking questions. I can continue getting code responses. But what I'm going to do here is I'm going to parse the code base myself. I can actually highlight certain parts of the code base and combine it with our action commands. So, write a test for this part, document this, even explain this snippet of code for me. And you'll notice that Augment's immediate context is already updated with that selected test. Now, when I go to a certain part of the code, this is where our auto completions kick in, right? I can start typing, and Augment's going to auto-populate the next line of code for me. Now, you're sitting there probably thinking that, of course, it's going to show confidence. It's a demo. What's actually happening is Augment's looking at similar data structures across the code base and auto-populating the confidence parameter that's already present there and matching the type because it understands that's my most probable intent. Now, our auto-populations are very quick, but if you don't like what you see, just keep typing, right? So maybe I want to add an update confidence method. Great. It automatically understands that this confidence field has been populated recently, and I'm going to use that as my method input. Now, this is what's called recency information. So Augment's going to match the stylings and syntax of your code base as is, but we also understand that maybe you're working on a new framework. Maybe you have an update in some of your instructions. So Augment doesn't treat your code state as static. It actually understands, the iterations that have happened. So if a string equals ABC, maybe the string equals AB 2 iterations prior. So Augment's going to actually continue to adapt to you and your coding patterns the more and more you use it. Now, this is the segue into some of our more agentic flows, where it's never going to be 1 or 2 lines of code change, right? It's going to permeate across different parts of the code base. So you're going to notice down here, Augment's already telling me how to populate my next change, which is our next edit feature. With a simple keystroke, it's going to actually walk me through different parts of my code base and make the relevant updates, where now I'm not only focusing on one test or one setup, it's actually going to help me for the entire task at hand. I can continue on with the chat and continue on with code completions, write my tests. But let's talk about what people are most excited about, some of our most used features, which is agents. Now, everything I showed you with agents is going to be exponentially expedited for the whole developer productivity matrix. We have 2 modes with agents, right? We have an agent auto and an agent manual. The difference is manual mode will allow you to explicitly allow certain tool calls, versus auto mode, the agent will autonomously take the decisions on its own, make the changes, make the tool calls, etc. So everything I showed you right now, right? We looked at this ticket AU6146. I had to do the information discovery, I had to make the code changes, and then I'm going to have to open a PR after I do the push. I don't want to do all that context switching. I don't want to go through different modes and modalities. So I'll give you a quick discovery thread of how I use the agent to do the exact same thing. So when it comes to the agents, we also have a few configurations. As I mentioned prior, we can first go in and connect via OAuth native integrations. So GitHub, Linear, Notion. For our enterprise users, we also have Glean. We can also connect with MCP. And then lastly, we can have a specific shell configuration for the agent to use. So if you have certain environment variables or setup done, the agent can use that to start up the shell. In the same scenario, I had the agent explain the ticket, didn't tell it where to find it, looked at Jira, and then recursively realized that it's in Linear, found the appropriate ticket, and then I told the agent to make the appropriate code changes where the context engine kicks in. It goes in and actually does a proper read of the file instead of a basic grep, and then it goes in and makes the appropriate edits. So this PR you see right here was actually made directly via the agent without me having to switch into GitHub. I stayed within the IDE and I kept in the flow. It added the appropriate notes, it added release notes for the customer, and then even added my peer Matt Ball as a reviewer, as is our best practice. So the way I was able to sort of control that agent is similar to guidelines, we have what's called Augment memories. So in natural language, I gave it some implementation guidelines, right? Create the detailed implementation plan, we follow this naming convention for the PRs and add Matt Ball as a reviewer, as you saw. But the beauty of agents is it's going to be able to actually go in and update memories on its own. So I was working on a ticket prior, and let's take that example where I can say, I want to add a Google SSO login button to my front end. I can say, search the web for the latest OAuth endpoint. Now the agent's going to kick off and it's going to start doing this thing. It's going to be able to search the web, and it's going to look for specific relevant developer docs where it's not just a generic search, but it's going to look for how do I implement it with the code base I see right here. And again, with memories, as you saw prior, it auto-populates things like I want to add the Google SSO front end, it connects it with the appropriate ticket, and then also figured out what the path for my GitHub file is. Now, the beauty of memories is the agent can recursively go in and update that memories file, so it shares that crucial context across all agent threads without me having to start from scratch in each section. We also implemented what's called a task list. So the agent is going to start to populate that task list with a plan on the steps it's going to take sequentially. And I can view the changes in real time, see the progress, or even edit the tasks or delete tasks as needed. The goal of this is, once I have the sequential implementation plan, I can update it accordingly. But with remote agents, now I can parallelize that, where the agent is going to be able to go in and spin off remote agents that work in the cloud, so I can get to my end state much, much quicker. As you can see, it's populated the task list, analyze, update the config, update my environment variables, so on and so forth. Taking a quick pause here, please keep asking questions in the chat. I see a lot of input going on. I'm also joined by my peer, Rob Kitaoka, who's, as one of me, a founding solutions architect. So he's there to answer any and all questions you might have. Now, one of our most exciting newest releases from agents is what we call remote agents. Now, remote agents takes the productivity boost of agents one step further, where now, instead of having an agent working on my local machine, I'm actually going to create a containerized environment hosted in Augment's cloud infrastructure, where the agent can take all the same tasks, have the same tool abilities, and work on tickets for me in the background. What this does is it's a parallel process, so I can spin up 5, 10, 15 remote agents that all work in parallel and takes all the toilsome tasks away from me so I can focus on the more complex, interesting problems. Let's take a look at my overall agent deployment. So right now I have a few idle agents where I can hop in, see the thread of what's been going on. I can see the actual file changes that took place. I can even go in and SSH into the environment itself, where I can either create a PR directly to GitHub, or I can pull the changes into my SSH VS Code workspace. Shifting gears a little bit, one last workflow I'd like to talk about when it comes to enterprise coding, right? We talked about how to create documentation, how to do information discovery, the beauty of agents and the tool integrations and data source integrations to kind of streamline the entire process from plan to submitting a PR. But refactoring is a very crucial aspect of enterprise coding as well, right? As code bases grow and become more complex, it's crucial that we go back in and re-optimize and review all the changes. So we're keeping up to date with newer patterns, more optimal libraries and solutions, and we're not causing a lot of tech debt or a lot of repeated work. So for my JetBrains fanatics, you're going to see that we have the same level of feature awareness with JetBrains as we do with VS Code. And you're going to notice things in the server-side code of my full stack app that I have a lot of console logs. That's not a best practice. What we really want is a logging utility that can be a reusable component shared by different team members, different components, and different applications. So I simply told Augment to abstract a logging utility and follow MongoDB's logging structure. Augment first shows me how to create that logger utility file. And using our quick create, it's actually going to place that file in the appropriate file path and directory for me. Following that step, it tells me how to actually update my server code, and using our smart apply functionality, it's going to open up this nice little native diff view where I can accept the changes one by one, or accept them all. And now in under 10 seconds, I've refactored my server code and added that appropriate logger utility. Here's what I want to point out about our context engine, where Augment understands it's never going to be this first iteration of change. It's going to, again, permeate across the code base. So you're going to notice that Augment actually doesn't stop just at the server file. It realizes that I should probably update my auth middleware as well. So it's going to tell me the appropriate changes, and it's going to continue on across the code base until I'm done with the full feature instead of just a simple task or simple 1 or 2 line change. Lastly, for the demo, what I want to point out is how we help the team sport of enterprise coding when it comes to documentation and collaboration. With this little shareable links feature, you can actually create a web instance of your chat history, where now, instead of having a TLDR or a generic summary shared with my teammates, I can just give them this URL, which is only accessible by people in your tenant. And they can see the input, output, the logic flow between me and Augment, and actually see the specific code, which can be copied into their own workspace as well. And this persists for the lifetime of tenants. So we actually have a lot of customers who've abandoned the traditional setup of documentation and just keep a repository of these shareable links as their source of truth.